Thank you for
So, on some blank note sheet, I want you to write down. Now, did I write down a sequence or a series right there? I wrote down a sequence. So a series is the sum of a sequence, but that's a sequence, 1, 2, 4, 8, 16, 32. If I asked you to find the next term, I'll give you a moment. So write down. Michael, are you okay? I understand if you're not feeling good. I've been there. So 1, 2, 4, 8, 16, 32. Write down the sequence. I don't think it'll take much. Just think a little bit. Is this an arithmetic sequence? And the reason it is no is because we're not adding or subtracting the same number, right? So instead we're not adding, and we're doing something else that's also simple. And so instead, what are we doing to find the next term and the next term and the next term? And we're multiplying times 2. So if I asked you, what is the next term? I think you would see the next term is, and then 128 and so on. Now, when we did arithmetic, the big idea was that arithmetic means linear. It's a way to describe a linear equation. This is not linear. So what I want to do with Desmos is I want to turn these terms into points, plot them on Desmos. Oh, I don't want to do that. What's it doing? There it goes. All right. I want to turn those into points. I want to plot them on Desmos and look at the curve. Or like, what do you think it is? It's not linear, so what's the curve describing? So let's try that. So the first term is 1. The second term is 2. The third term is 4. The fourth term is 8. The fifth term is 16. And the sixth term is 32. So when I look at that curve, do you have an idea what it could curve into, what type of function it could be? It's not linear. Any ideas? So one said exponential. Any other ideas what it could be maybe? Quadratic. Any other ideas? Could be like cubic, right, or something? Probably not, right? But let's look to see what's true about that, if that's true. So, on your phone or on a Chromebook, go to Desmos, and I want you to plot those and look at the curve and see what the curve reminds you of. It is definitely a function we've done in the last couple weeks. So again, you don't need more than one. So you just go 1, 1, and then the next one is 2, 2, and it'll just keep plotting them. Should keep plotting. What's wrong? Needs a comma, right? There it is. Thank you. Comma in between them, and then it'll be just pretty. So I want us to look at the if you connect to the points, what kind of curve does it look like? And you might need to expand this so you can see all the points. So those are all the points. So first of all, do you see a curve there that it's not linear? If you connected the points, is it curved? Yes, right? And curving up. So it's concave up like it smiles. So it would make sense if you took half a cubic or half a quadratic, or if you took an exponential. Could you see all three of those kind of curves, right? But which one is it of those? So if I said, hey, could it look like x squared? Do you see how x squared goes through the first point? Do you see how x squared goes through the first point? So it goes through the first point, but does it go through the other points? So does a quadratic match the curve of what we did for geometric? The other one is, I'm going to pick the ones that aren't right so you can see them. Cube is one I said. And so when you look at a cube, it does go in both directions. But for the one in the first quadrant, do you see it also goes through that first point? But it doesn't model the other points at all. So what was the other one? The one that, who said it to me first? Amelia, right? Which one did you say? Now, what does that look like? How would I write an exponential? I just did a quadratic, a cubic.
Isn't it like x cubed to x squared?
So exponential means where is the variable?
Oh, and that's right.
So I need a number for the, I want an aha moment. You ready? I need a number for the base. And what did I multiply to get the next term, the next term, the next term, the next term? So what do you think the number will be for the base for this one? So you're saying 2 to what exponent? Where's that? Here it is. Now, when I do that, it's almost modeling it, right? But it's not quite going through the points, is it? So instead, this whole curve needs to shift in what direction? One to the, which direction? Right. To the right. Now I know, do you know how we're going to do that? So, you're right, we're going to subtract in the exponent. So, oops, that wasn't in the exponent. So here, I'll put parentheses around it. So, if I subtract one in the exponent, now what do you see? Do they go perfectly through the center of each point?
Yes.
Does it model it exactly? So an exponential function models a geometric. Meaning if you're multiplying or dividing by the same number over and over and over and over and over again, what kind of model is it? It is exponential. What would you think if I multiplied by 3 every time instead of 2? What would change?
The base.
So that wouldn't say 2, it would now say 3. If I multiplied by 4 every time, it'd be a 4. What happens if it went the other direction? Let's say you started with a larger number and it was going down and you were dividing by 2. Like 8, 4, 2, 1, a half, like it was going the other direction. What do you think would happen? What do you think the base would be? Because I can't write down divided by 2. That can't be my base, right? Hey, my base is divided by 2. So it would have to be something that means the same as divided by 2, but you're multiplying. So if you're going down by 2, the base is going to be a half. If you're dividing by 3, the base would be a third. If you're going down and dividing by 4, it would be a quarter. So here's the big concept of geometric. Geometric sequence is an exponential function. A geometric sequence is a exponential function. Arithmetic was linear. Geometric is exponential. You say that out loud with me, right? So I know you know it, you know it, you know it. Geometric means exponential. And the base tells you what you're multiplying, right? And notice that in the exponent, what did I have to do so it matched it? Is I had to subtract 1 in the exponent, yes? So it matched up. So now, when I give you the formula, right, for geometric, I hope it's going to make sense that it matches. Now, we have a name for the number you multiply over and over again. It starts with an R. You know what it is? It's a ratio. So for an arithmetic sequence, we have a common difference. For a geometric, we have a common ratio. And the ratio is the base of the exponential. We're going to do it again, right? So you listen and know it and all that, right? The base is the common ratio. The common ratio is the base. The base is the common ratio, right? Remember the common difference was the slope, and I had to say that, and you still forgot it? That the common difference is the slope of the line, right? Here, what's the base?
The common ratio.
What is it again? Is that true, Alyssa? I think it is. That the base is the common ratio. That geometric means exponential, right? And notice how we had to subtract 1 in the exponent for them to line up, and that the curve went right through the heart, right, of every point. All right, ready to go? Did someone grab a packet for it? We'll see. So now we're ready. Let's do this. So this is part 1 of the lesson today. So what is a geometric sequence? So it's a set of ordered numbers with a common ratio. The common ratio is the quotient of any two consecutive terms. So first of all, what is a geometric sequence? It's a set of ordered numbers with a common ratio. What is a common ratio? So the common ratio is the quotient of any two consecutive terms. If you take any two consecutive terms and divide them, it will give you the common ratio. What I need you to know is this is what type of function that we're talking about. So arithmetic meant linear. Geometric means exponential. So, you're allowed to use your calculators. Will it make sense to you that these sequences and series could be very large in general? Do you know why they're very large? Because it's an exponential function. It's growing rapidly, yes? So the answers could be 50,120 or 1,200,000 and something. I'm not asking you to do it in your head. I'm asking you to take out your calculator. And if you didn't bring your calculator, you can use Desmos to do it. So, using your calculator, can you determine the common ratio and then find the next three terms? So, what letter do we use for common ratio? R. How do we do it? We divide any two consecutive numbers. Now, if I have a fraction, I'll probably try to use two consecutive integers and divide them. So in this case, what's 24 divided by 8? And then it says find the next three terms. So what would I do to 216 to find the next three terms? Times 3. So use your calculator. You get 648 times 3. You get 1,944 times 3. 5,832. I want you to look at number 3. We're going to skip some because we have a double lesson today. So number 3. Can you tell me the common ratio for number 3 because you have a calculator? It's important that when you do the quotient, it's the second number divided by the... So the common ratio is the second number divided by the first number, right? The order matters. You got to go the second one over the first one. So in this case, it's negative 16 divided by negative 6.4. It's going to be a fraction. You need to leave it as a fraction. So don't go dime and enter. Just write down what the fraction is. So negative 16 divided by negative 6.4, what did you get? 2.5 or 5 over 2. Could you multiply it? You're right. It's probably just as easy to use 2.5. Can you find the next three terms for me using the common ratio 2.5? So negative 100 times 2.5 is negative 250. Again is negative 625. Again, 2.5 is negative 1,562.5. Mr. Gomez, do I want to know? Okay. I was going to let it go for a bit. Okay. So what is a geometric sequence? A set of ordered numbers with a common ratio, which means you're multiplying or dividing by the same number over and over again. All right. Is there a formula to use for a geometric like we do for an arithmetic? And the answer is yes. We're going to start the same way as we did with arithmetic, with an. And what type of formula is this going to be? It's going to be exponential, because you've been listening to me. And the exponential one is going to start with the first term, a1, and we're going to multiply, and the common ratio is going to be the base. And what's going to be the exponent, so the points line up? N minus 1. Could you see on Desmos how we're subtracting 1 in the exponent? So they line up. There it is. I know you've seen that before. Does it now remind you of something that you've seen before? A1 times r to the n minus 1. A1 is, of course, the first term. And the reason we're writing this down is because in a month, in a year, in 3 years, maybe you need to go back to your notes, and you're being taught this, that you want to go back and remember what you forgot. And r, of course, is the common ratio. So write an explicit rule. An explicit rule does not use the term before. An explicit rule is one where if I want to know the 20th term, I just plug in and find the 20th term. So to do the explicit rule, we use this rule above. That rule above is explicit, that formula. The first term, a1, is 3. The common ratio, if you take two consecutive numbers and divide, so 12 divided by 3 is 4. So the formula then would be a1, the common ratio to the exponent, n minus 1. It says find the 8th term. So with that formula, take out the n and put in 8, and now use your calculator. And I'm telling you, in this lesson, the answers are going to be large because you're multiplying. It's exponential, right? So you're going to get large answers. So don't be afraid if you see a long number in your calculator and think, oh, I must have done it wrong because it's a big number. So in this case, the number is 49,152. Let's look at number 8. Could you come up with an explicit rule? And could you use that rule to find the 8th term? So I need to know the first term. In some ways, geometric's easier to work with than arithmetic, just because the information's just a lot easier to get that you need. So that's negative 100,000, right? So negative 100,000. Do you know how to find the common ratio? You have to divide. In any of the two numbers you can divide. Oops, there's too many there. Did you divide it? You're either going to get negative 1/5, or you could have gotten negative 0.2. Yes? So then what's the explicit formula if that's the base? So A1 is negative 100,000. The base is negative 1/5 or negative 0.2. Both are correct. And then what's in the exponent? N minus 1. How would I find the 8th term? You'd plug in 8. And then use your calculator. Now this is decreasing. So the number is going to end up being very small. Do you notice the ratio, the absolute value of the ratio is less than 1, so it's decreasing. Also notice that when you have a common ratio that's negative, do you notice what happens to your terms? It goes negative, positive, back and forth. That's a good indicator to know it's also not arithmetic when the signs change back and forth. So if you did it to a decimal, with your answer positive 1.28. Turn the page. Number 11. So in this information, you're not given a sequence, but information about the sequence. Can you take the information about the sequence? And can you find what you're looking for? So in this case, you're given the first term, which is 240. The common ratio is -2, and I'm asked to find the sixth term. So do you understand the explicit formula? And then plug in the information you're given, and then use your calculator. Could you find the sixth term with this information? Are you okay, Jose? Okay. I understand you. So, using your calculator, the answer is -7,680. And it's okay when you use your calculator to just put in 5. That's less of a headache, isn't it? Like just, you know what 6 take away 1 is. So just write down the exponent as 5, and you saved yourself a headache typing it in. All right, number 12. In number 12, it tells you the second term is -8, and the ratio is what number? 4. Could you find the 10th term? So I want you to think, if you know the second term and the common ratio, how would you find the first term so you could use your formula? Close. Divide, right? So instead of multiplying by 4, if I'm going backwards, what would I do? Divide. So what's the first term then? And it makes sense because -2 times 4 is -8 and so on, right? It fits? So the first term is -2. So if I want to find the 10th term, I start with -2. The common ratio is 4, and then the exponent is 10 subtract 1. Use your calculator. And you get the answer -524,288. Let's look down at number 15. In number 15, you know the first term and you know the sixth term. Could you find the 12th term? So what's not given that we've been given all the way through here is what the common ratio is. Do I know two consecutive numbers? Do I? Okay, good. So, you know the first term and the sixth term. Are they consecutive terms? No. So now what do I do? And here, I'm going to give you the answer to that. We are going to take the two terms we know, and we're going to divide them. This is how we're going to find the common ratio. So what two terms do I know? 486 divided by 2. Then we're going to do a radical to find the ratio. And to find the radical, the index of the radical is by subtracting the term numbers. So 6 take away 1 is 5. It should remind you of a slope formula, but we're using it like a radical. Can you find the fifth root of this, and that will give you the answer? Can I remind you what I did again? I took the last term divided by the first one I know, right? 486 divided by 2. And then I used a radical, and the index of the radical was found by subtracting the term numbers. Now I'm going to use my calculator. So if I had my TI-89, I would have 486 divided by 2, and then the exponent button, and then I need parentheses, and I'd have to put in the fifth root. That's what I'd have to type in to know how to be able to evaluate it. So can you type that in with your TI-89? With your Nspire, there's a button where you could actually do the fifth root and just go directly to it. Do you have it yet? Just haven't had enough time to go to the library. I got you. Maybe today will be the day. So, what answer did you get? Did you get 3? Is that what that means? Do you want me to remind you how I did that again? So if you know any two terms in a geometric sequence, right? Any two, not in order, how would you find the common ratio? You would divide, and then it would be a radical, and you would subtract the term numbers to find the common ratio. So in this case, the common ratio is 3. How do I find the 12th term? So then the 12th term would be the first term, the base is 3, and then it's 12 take away 1. All right, use your calculator. Can I just quickly go back to number 13 and tell you how quick this can be? In question number 13, you're given the fifth term, and the common ratio is 1/2, and you're asked to find the 11th term. It's not asking you to find the 100th term. If you know the fifth term is 1/4, then how would you find the sixth term? Is you'd multiply it times what? 1/2, and the seventh one times 1/2, and the eighth one, and the 9th one, and the 10th one, and the 11th one, and that would give you the answer. Or, if you're really with it, how many 1/2s did I use? 1, 2, 3, 4, 5, how many? 6. Did you see that? 1, 2, 3, 4, 5, how many? 6. That's another way of saying 1/2 to the what? To the 6. Notice we have 5 and 11. That 6 obviously comes from by subtracting, right? That if you know the term, a term, and the ratio, you can set up your own exponential and do it quickly. So if you did that, the answer was 1/256. I just wanted to show you that quick. All right, I'm going to remind you about explicit versus recursive. If I do an explicit one is going to be what we've been doing. An explicit one requires you to understand the first term, which is 2. How do I find the common ratio? Is I divide, and that's -10 divided by 2, which is -5, and then the exponent is n-1. That's explicit. For recursive, I start the same way, but what it needs is the term before it, and then what do? Is I multiply, and in this case I'm multiplying every time by -5. You could also put the -5 in front, and it would mean the same thing. So whether you multiply behind or multiply in front, do you remember the setup between explicit and recursive? Like in number 18, if I want to find the common ratio, I take two numbers and divide them. But I know that dividing fractions means the same as times the reciprocal. So right away I'm going to go times the reciprocal. The 3's cross out. A negative times a negative is positive. and 2 over 4 is just 1/2. So when I set up the explicit, the first term is negative 4/3. The ratio is 1/2 to the exponent n minus 1. So if we're dealing with fractions, it's good to remember that when you're dividing fractions, you go times the reciprocal. In the recursive, we take that 1/2 and we're just multiplying it every time to get the next one. The difference between explicit and recursive. Turn the page. So, we talked about arithmetic means. So, if you have two terms that are not consecutive, the terms in between those non-consecutive terms are called means. And that's also true for geometric. So, a geometric means are, if you have two terms that are not consecutive, the numbers in between them are called means. And I know the screen went purple, now it's going back. I know it's hard to see a little bit. So the terms, oh, you're going to come back? Maybe? Thank you. So the terms between any two non-consecutive terms in a geometric sequence. Hey, Michael. Feeling better? So, what are the geometric means between 3 and 243? And the answer would be 9, 27, and 81. Those are the terms in between, right? So, I'm going to repeat myself, right? We good? I'm going to repeat to remind that the key is to find the what? The common ratio. I was trying to teach you how to do it with your calculator. So if I repeat again, right, we'll remember it. So we're given negative 4 and negative 2,500. Yes? So if I set it up, it would be negative 4, blank, 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 and then negative 2,500. Yes? That's what it means by find the three means, right? The three numbers in between. But to do that, I need to find the common ratio. This is a question that requires a radical and your calculator probably, okay? So how do I set up the radical? So what goes underneath the radical sign? What's the last number and then the first one? Negative 2,500 divided by negative 4. And then what's going to be the index? So what term number is this? 5. And this one? So when you subtract it, it's going to be the fourth root, right? So on your calculator, how are you going to put that in? Negative 2,500 divided by 4. That arrow, the fourth root means the exponent is 1/4. And you have to use parentheses. So can you go negative 2,500 divided by 4 to the exponent? That's like a little arrow, 1/4. Use your calculator. So when you practice, you'll do better on the quiz. So the common ratio is what number? Did you get 5? So now, how am I going to find the means? Is I'm going to multiply by what number? 5. So negative 4 times 5 times 5. Oh, it's going to be what answer? A negative number. Times 5 times 5. How will you know if you did it right? If I multiply it times 5 again, does it match? And it does. So what are the three geometric means? And the answer is negative 20, negative 100, and negative 500. All right, let's try number 21. All the questions I'm not doing, the answers will be in a folder on my website. So you can still look at it and know if you did it correctly. So let's see if you've been listening to me again. How do you find the means? You try, then I'll show you. And use your calculator. Now, it's okay you have a negative number under a radical if it's an odd radical, right? So in this case, to find the common ratio, what kind of radical am I going to use? 4 take away 1. It's the cube root. Is it okay if the cube root is negative? Yes. So what's the cube root of that? And if you get a long decimal, you know, like negative 0.6666666, that thing, then don't press diamond enter, just press enter, and what's the number? Did you get negative 2/3? Okay, next, is that number already in your calculator? Then don't erase it. You know what the next button you should press? Times. Right away. Press the multiplying button, and then put in what? And then press what again? Multiply, right? Enter, multiply, and keep going. Times negative 2/3, times negative 2/3. And what are the geometric means there? So the next one is negative 162. Again, multiply. Put parentheses when you multiply it, right? Around the negative 2/3. And again, multiply. And what answer do you get? Positive 108. Those are the two geometric means. Are you going to remember how to find the common ratio when you don't know two consecutive numbers, right? All right, let's do some stories. And then this lesson's over. And on to the next lesson. Like a double header in baseball or a double feature. Go to the movie theater, you get to watch 2 movies. Here we go. In 2009, Ava purchased a new truck. That'd be nice. For $45,000. Each year, the value of the truck depreciates. That's a big word. Are you listening to me? What does the word depreciate means? Going down. Decreasing, right? At what rate is it decreasing? 18%. Use a geometric sequence formula to find the value of the truck in 2017. You ready? All right. So, can you write those down? And can you tell me what they are in the story? R, A1, and N. Start with something easy. What do you think A1 would equal? The initial price of the truck, which is $45,000. I'm going to tell you the one you really have to think about is R. So I'm going to let that go for the end because you have to think. But N isn't that bad. 2017, if you started in 2009, remember what we did when the counting principle? What did we do? Subtract and add 1. So if I subtract and add 1, what term number is it? It's actually the 9th term, right? If you count. So if you want to know, if you started 2009 and end at 2017, subtract it and add 1. That's the term number you're looking for. Do you know why you need to think a little bit about the common ratio? First of all, if you ever want to find the percent of a number, you know you multiply, don't you? What's 10% of something? What do you do on your calculator? You multiply, don't you? Times what? You multiply, that's why it's geometric, right? You multiply times what? So you change the percent to a decimal. But there's a problem here. So first of all, do you know that? To find the percent of a number, you multiply by the decimal. Yes? Okay. Now, here's the problem. It depreciates by how much? That's how much it's losing every year, right? But I don't want to know the amount that's losing. I want to know the amount that's kept. So if something's going down by 18% every year, I don't want to know the 18%. That's how much you're losing. I want to know how much is left. Get what I'm saying? So instead, what I have to do with that, in other words, I need to take 100% and if you're losing 18%, what percent are you actually keeping? So the question is not how much are you taking off the price of the truck. The question is how much is your truck worth now? So if you go times 0.18, all you're doing is finding the amount that you should subtract from the price of your truck, not what your truck is worth. So how much will your truck is worth? What's going to be the common ratio? And the answer is 0.82. Did you see how I got 0.82? So 18% is how much you're losing, but I want to know how much you are keeping. Like, what's the worth of the truck? If I go 45,000 times 0.18, that is not the price of the truck after 1 year. That's just how much you're losing. So how much are you keeping? And the percent is 82%. All right, now we can figure this out. So in 2017, what's the truck worth? So it started at 45,000. It's keeping 82% of its value, right, every year? It's losing 18%, but how much is it keeping? 82% of its value it's keeping every year. And then you go 9 subtract 1. Go for it. Notice the exponent would still end up being 8. Yes? When you do the math here. So can you use your calculator, please? How much is the truck worth in 2017? All right, let's read number 24. So read that story. You want something disheartening? I looked up. Do you ever know what Kelley Blue Book is? Kelley Blue Book is something you go to find out the value of vehicle. Like if you want to know, hey, before you trade it in, or want to know, like, hey, what could I sell it for? It's like a website where you can go in and say, hey, I have a 2002 Toyota Tundra. Like, how much would I get for it, you know? Yeah. No, honestly, it was like you could get anywhere from $400 to like $1,000, you know, for your truck. So it feels, man, somehow it's like worth more to just drive it. That's not a lot, right? For a truck. Anyone want my truck for $400? Okay. When I sell it, I'll let you know. 24. All right, Garrett. Anybody a Cowboys fan? He's going to be fired. Garrett signed a new cell phone. Then you don't know who Garrett is if you're not a Cowboys fan. Yes, of course. All right. Signed a new cell phone contract in 2014. The table to the left shows his average monthly bill in 2014, 2015, and 2016. If this pattern continues, use a geometric sequence to find his average monthly bill in what year? 2025. So first of all, this would be geometric if the common ratio is the same, right? And to find the common ratio, all I have to do is divide. And that better equal the same as this, right? If it's truly geometric, both of these would give you the same answer. So 76.5 divided by 75, 78.03 divided by that. What do you get for the common ratio either way? Did you get 1.02? You're allowed to use your phone in Desmos and participate, other than other things you do with your phone. Next, I need to know the first term. Well, the first term is how much? 75. And then how many terms do I have? Well, which year am I looking for? 20. So how would I find the term number? What would I do to 2014 and 2025? Subtract them and then add 1. So what term number is that? So the 12th term would be found by doing the first term, which is 75, the common ratio, which is 1.02, and then it's to the exponent 12 take away 1. And in your calculator, you would just put in 11. So in the year 2025, how much would his cell phone bill be that month? And the answer is $93.25. All right. There's your lesson on geometric sequences, Mr. G Math. Over and